Welcome to Qt Widgets and More. Have you ever wondered what the difference is between update and repaint? Well, I know, and I wanted to show you, and that sent me down a rather unexpected path for a journey I'm not sure I wanted to take. Stay tuned to learn more. In QWidget, there are two different methods, repaint and update. Both are supposed to get you pixels on the screen. But what is the difference? Let me admit up front, I have not used repaint since like 2000. So this episode here is really just showing you a very unexpected journey into process event and other interesting things. Let's get started. So the application is relatively simple. What you see up here is the full application. It's just an area where I can change the color by pressing update. And let me show you the source code for this. It's a subclass of QWidget. It has a paint event. Obviously, otherwise we wouldn't be seeing pixels on screen. And in the paint event, I'm choosing a random color here. I'm creating a painter on this, meaning I'm painting on the widget itself. I'm filling the rects of the full rects that the paint event told me to paint, and I'm sleeping for 100 milliseconds. My size hint, 500 by 500, otherwise it would be rather difficult to see because it would then be 0 by 0 or whatever the layout manager forced it to. So the width of the button times 0, I guess. My application is down here. I created a widget, a layout manager, and here's my widget that I created. I added that to the layout manager. I added two buttons to the layout manager. One button is calling update on my widget foo up here, and the other one is calling repaint on the widget foo. This one is doing it 3 times because I'm going to set some breakpoints, and it was pretty annoying when I needed to go through 10 breakpoints before I was done with this loop. This one does it 10 times. And let me show you right away why I do it 10 times. So imagine again, I'm calling repaint 10 times, and in the repainting, I'm sleeping for 100 milliseconds. So it looks like this. Obviously, you saw that the color was changing 10 times. Not too surprising, but nevertheless. But what you also might have seen was that there was these tearing lines on the user interface, and that's because that the repaint really just goes and say, let's get those pixels on the screen right now. And you think, hey, it's just those 100 milliseconds that is the issue. Well, let's comment them out. Let's run it again. Coming up real soon. There we are. And repaint. And it does it much faster, but you can see there are still these lines where, yeah, it doesn't look too good. In the old days, one of the issues that we had here was double buffering. But Qt actually does double buffering for us now. But that's not the issue. The issue is that I'm painting something new on the screen in all of these paint events. But let's have a breakpoint in here so we better can see where things are caught from. So I would like to just put a breakpoint in the repaint method or in the paint event method, but that would be slightly annoying because I would start my application, it would get a paint event, the breakpoint would be hit, I would have to press continue and get focus back into the window, and another paint event would be generated. So instead, let me put a breakpoint here on the place where I call repaint. And now when I hit the breakpoint, I'll create, so repaint. Now I hit the breakpoint. I'll go up and find my method for repainting. Up there. Set a breakpoint there and continue on. And now I hit the breakpoint point for repainting. And what I'd like you to see here, let me just make this slightly bigger here. What I'd like you to see, just follow over here. So I'm in the repaint method here, and we can see the back trace here, lots and lots and lots of stuff going on. But you can see if I go all the way up here to stack frame number 24, that was actually where I called repaint. So it's just a regular function call going on down there. Let's just try and walk a bit down. It's just so we can get a feel for what it looks like. Repaint calls, well, repaint, which called repaint on the dpointer. Remember that episode where we talked about the Qt source code? That's the other object that sits behind the object. That's for binary compatibility reasons is sitting there. But there's a link here for that episode. Then going down there, testing some stuff. And if the Dirty widget send update request, and here's actually something rather interesting. You can see here that there is a update later or update now. Let's see. I already put a breakpoint or mark there. Of course, I'm going to go back to that. And let's just look here. Repaint, and we're going through the repaint manager and lots of other stuff. And further down here somewhere, we get to event method, and the event method is in QWidget. That's the way that QWidget is implemented. It calls paint event, which is the virtual method that I overwrite, over whatever this version down here. So calling repaint is really only through, 23 levels of indirection calling the paint event method. So let's try the same exercise again, this time hitting the update button instead of the repaint button. I got into the place where it got called, and I will set the breakpoint up there. Press F5 to continue on to the paint event. And let me just make this bigger here. I'm afraid I can't change the font size, but what you'll notice if I just expand for more here is that we are in part1.cpp. That's this file here. But if I go up, and please follow careful, you'll see there are no other references to part 1. All I see up here is main.cpp. So there are no backtrace where I can just go up from the paint event to the place where I called update. So why is that? Well, that's the difference between sending an event and posting an event. Repaint sent the event, which is just a fancy way through 23 level of indirections or so of calling the event handler. Post event, on the other hand, takes the event, package it up in a small package that it puts into the event loop or into the event queue. The event loop runs around and eventually get to that package, and then it will execute it. And if you look at the backtrace before, you would actually notice that there was the event loop all the way to the top. Let me show you my update method again. I already ran it again, and I put a breakpoint, and I'll go up now, and I'll show you where exactly the event is posted. So here's my update again. If I go up, there's these recalling updates. Then there is the going to the repaint event manager, and then send update request. Sounds like sending, but if we go down here, you can see that it says for whether update time should be later or now. Repaint is marked as now, and update is marked as later. And you'll notice that it will post the event. Obviously, that do not answer why we are not seeing more than one repaint when we update. It could have been that I posted the repaint request so many times that the event queue would be filled up with them. But for that, let me just go one level up. Here is the test for dirty widgets is empty, and let's just put a breakpoint here, continue again. And now we'll notice if I go up again that I'm down here, I is now 1. I can continue once more, and I is 2. So this is the loop that is running around. And up here, if dirty widgets is empty, but as we can see, I can just step here. You'll notice that I'm stepping over this stuff here. So this is actually the place where update events are compressed. It tests whether there are actually whether the widget is already marked dirty. And if so, that means that, hey, we did request a repaint eventually, so no need to put in another request for that. So the update will simply not put anything in the event queue at this point. Yeah. I should have shown you the complete debug session. That you would be being bored to death because there's many levels going through there that needs to be understood. I did obviously do the complete debugging session, but I thought I'd just show you the end result. In the handout that you can find below, you can find this application. Try doing it yourself and follow it down. It'll give you some insight into what is actually going on inside of Qt. And I'm already at 10 minutes of this recording, and that's why I didn't show you the complete debugging there. And I wanted to show you a few more things that I was puzzled about when I did the preparation for this recording. Namely, how about other events? We saw that the update was compressed, but only one of them would go into the event queue. So I wanted to see if there was others. And I knew from 20 years of teaching Qt that obviously mouse move event was compressed too. So let me see how that looks. I got another example here, part 2 now. And in here, you'll see the widget. It implements mouse press event, mouse move event, and paint event. And the only reason why I do that is that I can show you that I can actually draw in here. If you follow the introduction to programming with Qt training that we are putting out right now, then you'll actually see this example from there. There's one change though. If you look at my move event, I'm sleeping for half a second. So if I move around here and let me move the cursor slightly faster around here, you'll notice that it is actually drawing larger line segments here because that I was, let me zigzag really fast here. You can see that I am getting these. That's simply because that there's half a second, or it only samples where my cursor is every half second. So it does event processing right there. Did I say event processing? Well, I meant event compression, but I guess my brain just did not want to say that because after 20 years, I learned that to only be true on X11. Or more specific, when the underlying platform was XCB, I tried switching to Wayland on my Linux desktop, and there was no event compression. That's actually pretty scary. So I talked to a few coworkers of mine, and what it turned out is that it's the XCB platform integration that does the test. And there's a link below where you can see that it actually does a test for whether the next element in the event queue is a mouse move, and or the first element, and if it is, then it will not do any, it will not put any more in so that I get this. Let me show you that I can actually turn it off, and I would suggest that you turn it off unless you only target Linux X11, because otherwise your Windows users or Wayland users might be slightly annoyed by your delays in repainting. The line to disable XCB's smart behavior of compressing event is this one here. Simply call on the Q application, say set attribute compress high frequency events false, so that it will turn it off. And what you'll notice is that when I do some drawing up there, it will actually get all the events in. Why would you want to do that? Well, again, it is likely, can I say that in, yes, it is a bug in your application if your paint event or if your mouse move event in this situation here takes so long. If you have something that is complicated and needs to be done on that, well, send it off to another thread. Let the other thread do whatever needs to be done, and then get the result back to be repainted whenever it's ready. Mouse move event that is long will hit you on other platform than X11, so better get your hit right away here by adding this line to your application. What? Really? You tell me now? I was just notified that Windows actually do have these kind of compression built into it too in its platform layer. But it's not in proper Qt. It's not in the part of Qt where all the execution goes from. It's in different plugins, XCP, Windows plugin. Wayland, as we saw, did not do it. So better not rely on that kind of information. And that brings me to the last kind of compression I thought I knew about and that I wanted to show you. Namely, move and resize. And observe here, I'm moving my window around. It again has 500 milliseconds here and 500 milliseconds for move and resize. And you can see it do not, despite that I'm moving around a lot, it doesn't get a lot of move events in. Similar, if I take my window and I resize it, you can see that it doesn't get a lot of resize ins. It's just get in as fast as it can cope with them. So I don't end up with 200 resizes that I need to address later on. Obviously, everything I've been telling you today is with my Qt 6. I'm sure that things are different in interesting ways for Qt 5. But again, we debugged our way, and I had Giuseppe help me out here to look very careful in Qt, and it turned out that it was not in Q application : compress event that this happened. Actually, I didn't see anything happening down there. Maybe that was just my debugging skills. But in any case, this was completely different. It was in some spaghetti code somewhere, but that at least seemed to be cross-platform, so that you can rely on that you will not get expensive resize events getting in. Again, if your resize event or your move event for the window is taking a lot of time, then likely you should introduce some multi-threading in there. I've had it like sitting up all night, writing an essay just to come to the conclusion that the topic I was researching wasn't correct, but I handed in nevertheless because now I had created it. I felt slightly like this for this episode, but I hope nevertheless that you learned something from all the attempts at figuring out what is compressed and what is not compressed. And until next time, have a great time.